Section 6.1 is on factoring using the greatest common factor. And factoring by grouping. So factoring using the greatest common factor, we notice that we first want to identify the greatest common factor. Which we'll also often call the GCF. We notice that if we were looking at 18 and 12, the greatest common factor is just the biggest number as factor of both. So we can make a list of the factors of each. So we can look at 18 has factors of 1, 2, 3, 6, 9, 12, 18. 12 has, it doesn't have a factor of 12. Whoops. 9 and 18. You notice that the 12, there's no integer that you can multiply by 12 to get 18. 12 has a factors of 1, 2, 3, 4, 6, and 12. And it's the biggest number that's on both lists is 6. So we can say the GCF of 18 and 12 equals 6. And so it's usually a pretty straightforward process. We notice that if we're going to look at the GCF of two numbers that have no common factors, so if we said the GCF of 5 and 7, we know that's just going to be 5 times 7 is 35. If we looked at the greatest common factor of two numbers that one is a factor of the other, so if we get the greatest common factor of 4 and 12, that's just going to be 4. So we notice that if one number is a factor of the other, it's easy. If the numbers have no common factors, it's easy. So the biggest trouble tends to be if we have numbers where neither of those is the case. So if we look at the GCF of 10 and 25, we generally have two, mainly our way of doing that is just look at the factorizations. So 10, we notice we've got 1, 2, 5, and 10. 25, we have 1, 5, 10, and 25. And so we notice the greatest common factor is 10. So once we've identified the greatest common factor, we notice that we like to factor using it. So the idea is if we were looking at something like 3x plus 12, we notice the greatest common factor of 3 and 12 is 3, and so we can write that as 3 times something, so that we get 3 times something equals the 3x plus 12. And so we notice that we need 3 times something equals 3x, 3 times something is equal to 12. And so we notice that for the 3x, we just can multiply it by x. For the 12, we can multiply it by 4. And so we're going to say 3x plus 12 equals 3 times the quantity x plus 4. And if we're ever not sure, we can multiply it back out. We notice 3 times x plus 3 times 4 is 3x plus 12. And so we know that that factorization was correct. And so whenever we get a factorization, we can always verify it by multiplying it back out, making sure it actually worked. So if we had something like x squared minus 4x, we notice that there's no constant common factor. but it's very easy to see variable common factors. We notice that we can write that as x times the quantity x minus 4. And that's going to be pretty common. We're going to do that a lot. So if we saw something a little more complicated, like 3x cubed minus 15x squared plus 30x, we notice now we have a common factor of 3 and a common factor of x. And so something we'll notice is we don't necessarily have to do it all at once. We notice that we could pull out the 3, which leaves behind x cubed minus 5x squared plus 10x, and then we could pull out the x. So we get 3x times x squared minus 5x plus 10. And we could also just pull the 3x out entirely in the first place. The main issue to watch for is we notice that there are no remaining common factors other than 1. And so notice we'll often have common factors of 1 or negative 1. We'll talk about that in a moment. We notice we can also, well, sometimes when we pull out a negative factor, we notice that if we had negative x squared plus, actually, we'll just write it as if we just had negative x minus 4, we notice that sometimes we want to pull out a common factor of negative 1, which leaves behind x plus 4. And so we're always allowed to factor out a negative or a negative 1 or a positive 1. And so we notice x minus 5, we could write as negative 1 times negative x plus 5 is true. We don't typically pull a negative 1 out unless there's a reason to. So we notice that if we have a negative coefficient of x, so if we were going to look at negative 2x plus 7, we might want to write that as, actually let's write it as, if we had negative x squared plus 4x, we might want to pull out a negative 1, leaves behind x squared minus 4x. Then we can pull an x out. We get negative x times x, the quantity x minus 4. But we notice that we don't typically pull a negative 1 out unless there's a reason to. We can pull the negative 1 out. But only do so if there's a reason. And we'll see some of that in a later section. So let's look at one that's just a little more complicated. If we had 3x squared y cubed, I'm sick of 3. We'll stop using 3. Let's do 5. If we had 5x cubed y cubed minus 15xy squared plus 30xy, we notice that the greatest common factor is 5xy. The biggest power of x in all three terms is x to the first, the biggest power of y in all three terms is y to the first, and then the biggest constant common factor is 5. And so we look at that as 5xy times xy squared minus 5xy times 3y plus 5xy times 6. Just to see a little more clearly, all three terms have a common factor of 5xy, and now we can pull it out, basically using distributive property in reverse. We get 5xy times that quantity xy squared minus 3y plus 6.